Hello everyone, welcome back to Chapter 11 of the TRO textbook, Chemistry, Structure, and Properties. And in this part, what we're going to do is we're going to begin our study of the differences between intermolecular forces. And so dispersion or London forces, dipole-dipole, hydrogen bonding, and ion-dipole. So these intermolecular forces are what actually determine the composition and the structure of the compound or molecule. And they are the attractive forces that exist between them. Okay, and so these intermolecular forces hold liquids and solids together. They are the reason why some things are gases, some things are liquids, some things are solids. And so the intermolecular forces and how strong they are going to be the pivotal piece of information that tells us how these things are going to react. So the attractive forces that hold matter together, okay, in a condensed state, which is liquids and solids, are electrostatic. And the strength of the electrostatic is in positives and negatives. The strength of the attractions is going to determine, like I said, whether it's a gas or a liquid or a solid. The stronger it's held together, the more energy it takes to break it apart. So it's going to have, if it's strong, it's going to have a high boiling point and it's going to have a low melting point. Okay, attractive forces can be very, very weak, okay, or they can be very, very strong. Now remember that these attractive forces between molecules can be temporary or they could be permanent, but every material is going to be moving in some way. All right, the only thing that has zero movement is going to be a perfect crystal at absolute zero. So since the intermolecular forces are due to these attractive forces, these electrostatic forces, you've got plus and minus. Okay, in a polar molecule, you've got a plus and a minus N. In a cation, anion, they're charged either positive or negative. And even non-polar molecules can have a temporary charge associated with them. So remember, the larger the charge, the stronger the attraction. The longer the distance, the weaker the attraction. So close together and big charge is going to be the strongest attraction between those two molecules. Now, intermolecular forces are not nearly as strong as bonding forces. Bonding forces are intramolecular. Okay, and intramolecular means between the atoms in the molecule. Intermolecular attractive forces are outside of the molecule itself, between molecules. So you can have one of two major types. You can have a temporary polarity or dipole, or you can have permanent polarity. Now, temporary polarity is what you see in those nonpolar molecules. Okay, those nonpolar molecules, and but they do still have an equal distribution in the form of dispersion forces. Okay, and these electrons are not always equally shared among everything. Even if they're not polar, they're still located in different places, and reacting to the forces outside the molecule can cause those electrons to realign temporarily and form these dispersion forces. So everything can have dispersion forces, but this is typically what you see in nonpolars primarily. So things with permanent polarity are those things that are going to be polar, okay, and they are going to have dipole-dipole attractions. Now, one of the strongest dipole-dipole attractions is hydrogen bonding, okay? And we see hydrogen bonding or H bonding in a lot of molecules. Now, what do you have to have in order to have a hydrogen bond? Hydrogen, okay? So you can't have a hydrogen bond if you don't have a hydrogen, so don't forget that part. So let's talk about these temporary things. So what the heck does this mean? Okay, so what happens in a temporary dipole, okay, and these will happen and then they'll go away, and then they'll happen and then they'll go away while these molecules are moving all around each other. And the instantaneous or temporary dipole occurs when something outside of the molecule attracts the electrons or repulses the electrons. So if you've got something positive out here, okay, and it comes close to your molecule, it's going to pull your negatives, your electrons, kind of close to that. And this is what we call these temporary dipoles dispersion forces. And the types of dispersion forces we typically look at are London forces or van der Waals forces. Okay, so as it comes close to a charged molecule, it's going to induce a dipole very, very short, very quick, but it goes away as soon as that other molecule moves away from it. Okay, but all molecules and atoms have dispersion forces, so whether you're polar or nonpolar, you're going to have these. The permanent dipoles, as we see, are where you have bond polarity. Your molecular geometry determines that you have the polarity in order to do this. And what happens is that you have an accumulation of negative charge, as in electrons, on one end of a molecule, which makes the other end slightly positive. And this is what we call a dipole-dipole, okay, because you have a polar and a polar, and they're causing each other to be attracted to one another. All right, and so that's our introduction to temporary dipoles and permanent dipoles.